Hello, welcome. Let's give another minute or so for attendees to join up and get settled, and we will get started. I see the number is climbing. It's slowed down a little bit, but people are still coming in. All right, that's enough. Hi, my name is Jason Jeanette. I'm a technical manager here at the DLC, and we have this webinar today, and we're talking about network lighting controls for small and medium buildings. Next, please. As we get started, we have a couple housekeeping things to say. The slides and the webinar, recorded webinar, will be posted on the DLC website, and all attendees are automatically muted, so don't worry about screaming at me, I can't hear you. Next, please. If you have any questions during the webinar, please put them in the question pane in your browser window, and we'll have some time at the end for a Q&A session and go through those. And next, please. Here's a quick overview of the agenda. We'll do some introductions, then we'll kind of go over what's the DLC, what are NLCs, what are LLCs. I'll talk a little bit about some new framework for setting them up. And then our guests will speak and we'll have a little roundtable discussion. And next. And our guest today, so I'm Jason Jeanette, I'm with the DLC. We have Franca Graz, who's the Director of Engineering at Facility Solutions Group, and Kirby Corkhill, a team leader at Jarvis Lighting. And they're going to share some of their experiences about NLCs, particularly in both large buildings and small and medium buildings, and some of the lessons we can learn from that. Next slide, please. As I'm sure you know, the DLC is an independent nonprofit organization. We provide decision makers with data and resources on quality lighting, controls, and integrated building systems to help reduce energy, carbon, and light pollution. So some of our resources that we can share with you next are we are working on a new version of our flagship program called the SSL QPL, or Solid State Lighting. The technical requirements draft 2 for version 6 will be out soon. And our focus on version 6 is really driving the adoption of connected lighting. We're both helping reduce more energy and really get those more integrated controls into those fixtures. Next, to that end, we've introduced a new concept called controls categories. This is a deep project or deep topic. We're not going to go into it here, but the short version is that each listing on the QPL will include controls categories for the control variations associated with that listing. And those categories run from 1 to 6, where category 1 means there are no integral controls on, it's just a luminaire. Category 6 means that is a product or luminaire with a network controller and 2 or more sensor functions built in out of the box. If you're interested in learning more about those, I invite you to read the TR and comment in our draft period that will be beginning in a couple weeks. And we'll have some webinars during that draft period that will go into this in more details. Next, please. We also have a number of publicly available resources. We have reports on how lighting controls can save energy, particularly network lighting controls, as well as interoperability and kind of future-proofing your building and your lighting controls with that. Next. We also have some resources available for helping people install those network lighting controls. So we have some best practice guides to help people understand, what is occupant sensing and why should I do this? We also have an NLC HVAC integration toolkit, which helps project practitioners decide if a specific project is a good candidate for NLC and HVAC integration. Integrating your NLC sensors with an HVAC system can save a lot more energy, but not every building is a good candidate for that. Next, please. In addition, we also have some member exclusive resources. These are exclusively for our utility members that include some recent research on technical reference manuals, which are the kind of policy documents that govern efficiency programs and rebate programs kind of across the country, as well as the DLC playbook, which is for helping efficiency programs move from incentivizing luminaires only, kind of stepping up to sophistication to incentivizing primarily luminaire level lighting controls. This is a good place. I lost that. Okay, next, please. So the big picture in all this, and next is there are approximately 3 million buildings nationwide that are smaller than 50,000 square feet, and according to the federal government at least, have no lighting control strategies installed beyond line voltage switches. If you combine those 3 million buildings with next, our DLC study showing an average of 49% energy savings with network lighting controls, that comes out to more than next 30 terawatt hours annually of energy savings potential. All right, my slides are running a little behind. Next slide, please. There we go. That's a lot of, so 30 terawatt hours is a lot of energy, and actually it's just under $4 billion worth of energy. So that's a huge amount of savings potential for this building type. So now we're going to go over some NLCs and LLCs, kind of quick level setting here. Next slide. Network lighting controls are lighting control systems where the controllers, sensors, and user interfaces are all connected together on a two-way network. Those systems can be wired, such as this one, or next, or use wireless communication. Next, a luminaire level lighting control system is a network system in which there is a sensor on every general lighting luminaire. We got a little way of dancing sensors here. Next, an LLC is a type of NLC. Next, NLCs can be connected to the internet or not. Next, and some NLCs will connect to the internet occasionally through a mobile phone. Next, there are several different network typologies. How they go? So some networks work on a mesh typology where every device talks to every other one. Some networks work on a star typology. Wi-Fi is like this, where there's a central device that talks to each other device individually. Or some work on a bus typology, kind of like Dolly, where there's a central line and each device connects off to that. But no matter what the network typology is about how the base things work, there are also a couple different ways of the network itself functions. Next. Some networks operate more like an orchestra, where there's a central device that kind of conducts everything. Next. So this may be a mesh network, but that central device is where all the kind of commands live. So when a button is pressed on one of these remote devices, messages are sent over the network to the central device, and then the commands are sent back out. Others networks operate more like next, a jazz band. Next, where each device listens to each other and responds accordingly. Why does this matter? Next, the way these networks function has to do with the amount of hardware that is required to make that network work. In many cases, for a large building, those projects may have hundreds or thousands of luminaires. That building may also have a building management system and a dedicated staff to run that building. In small to medium buildings, we're talking usually a much smaller number of luminaires, sometimes in the tens or hundreds. Typically, there's no building management system for that building. And the staff that runs that building usually have other responsibilities. The building's usually run by an office manager or a warehouse manager that is also doing other things. So understanding how a network functions has to do with how much hardware that you need to buy at the beginning of the project, where a network that runs more like a jazz band doesn't need an extra piece of hardware to function. So that keeps those costs down, and particularly upfront costs down, which helps with ROI over the long term. So that's kind of an overview of different types of network lighting controls and how they can work with each other, or how they can work. Next slide, please. So now this is an overview of how to set up a network lighting control system. And really there are 3 basic steps. Each step has a bunch of sub-steps, but these are the main things you need to know. Next. For any system, no matter what it is, you have to build the network. If it's a wired system, you have to wire up the devices and make sure they're all connected. If it's wireless, you have to join each node to the network, just like joining your laptop to a Wi-Fi network. Doesn't do anything unless you've built the network. Next. Once your network is built, you have to organize it. When devices join a network, they usually don't have a name that is useful to humans. They have some weird like 8 or 9 digit code, and the network understands what it is, but the system doesn't know where that device is. It doesn't know if it's in Kirby's office or out in the dumpster. So you have to tell the system where everything is by organizing all of those devices into rooms. And next, and then once everything is organized, you apply your control strategies. If you know what your control strategies are going in, that's pretty straightforward. So it makes sense. 3 steps. Yeah. So once you kind of demystify those steps, that'll help make network lighting controls much more accessible. All right. I'm going to pass it over to Frank, who's going to tell us a little bit about lessons he's learned on NLC projects. Frank, you're up.
Thank you. I really appreciate that. If we could go ahead and go to the next slide, please. So as we've been discussing, obviously this is about network lighting controls. I wanted to share with you just a few of the lessons learned as a kind of a turnkey retrofit provider. Next, please. As with any control system that is going to be going into an existing building, we really need to start with a decent audit. And when you're assessing those existing conditions, you really need to have controls in mind. And so what I mean by that is, as you're walking through the space, it is really important to capture all of those existing controls, and not just switch sensors that may be at the switch, but do we notice any dimming, any timers? Is there a daylight harvesting system in place? Have they already put in top-end and tuning, for example, because we're trying to capture that energy consumption. Also, we want to understand what kind of control zones are in place. For instance, are there primary and secondary daylight zones that we could take advantage of? Is there more than one zone where we need to kind of apply that to the commissioning side of it? Occupancy pattern also can really define what that NLC system will look like. Is this space set up for 24/7 with pockets of control availability, or is this more of a shift work situation where you could really grab some major time savings? Also, is there going to be a way to integrate BMS or BACnet controls? That's something that we should be paying attention to. And then, beyond the occupancy on off, is there a way to perhaps incorporate space utilization or inventory control? So maybe a little outside of this scope, but again, as a good auditor, that's something that we want to keep in mind. Next slide. So when it comes to the actual specification, we've learned that it is so important to really understand the customer's priority versus the features of each specific system versus what is that end user budget. We talked about flexibility within the system, whether it be a wired or wireless system. If the customer is in a situation where they may be reconfiguring zones and or groups often, maybe a wireless system may provide a little more flexibility to reduce cost. Also, we need to understand, is this system being set up with a kind of a set and forget with a lot of automation in place, or are we going to have some sort of personal and or user control put in place? App-based commissioning is also one of those features that can really cut costs when you're in the field getting everything set up. We talked about control-ready luminaires. Maybe within the entire project, maybe putting controls in 100% of the scope is not within the budget. So if you can specify a control-ready luminaire where you could then maybe come back into phase 2 or phase 3 and add onto that system. So speccing the right product up front can be very important. Along with that, are we going to be using a proprietary system or a system that allows other manufacturers to play together? And so that's something we need to keep in mind. And then also labor considerations with respect to controls. If you're going to be chasing EPACT 179D, or if we have a prevailing wage or union environment, that can absolutely affect the budget. Next slide, please. Just a few other considerations that we like to look at when we're designing systems. Number one, what kind of power are we talking about? And I'm not talking about wired or wireless, but I'm talking about, is this going to be a battery operated sensor as an example, or are they going to be line voltage? So, so wireless versus line voltage, those are two very separate things. So let's make sure we kind of know where to go there. Also, to the earlier point of scaling this system, are we talking about just a few rooms, or are we going to look at a building system, or are we going to look at a portfolio of buildings? So that'll necessitate the need for gateways and Cat5 connectivity and things like that. On a simpler note, we need to understand access to the ceiling with respect to labor and budget costs. Are these drop ceilings, or we can run hardware within a plenum, or is this all hard ceilings where labor is going to be considerably more? The zone and the group flexibility, we talked about that a little bit already. And then the last thing I want to bring up is just understanding that because this is a system that, especially on the wireless side, it's so important to work with the end user facility IT folks. We need to be able to coordinate with that group, because not every facility has the same sort of flexibility, and Kirby will talk about that here in a little bit. So with that, I'll turn it over to you, Kirby. Take us home.
Cool. Thank you very much, Frank. I'm Kirby from Jarvis Lighting. I'm really excited to be here, and I also was really excited that I got to go right after Frank, because Frank and I come at the industry from two totally separate project sizes. So Frank has a lot of expertise dealing with a lot of bigger, complicated projects. I've got some of that expertise. I've also got a lot of experience doing lots of small buildings. So it's a little bit of a different take because it's a different environment. The one saying that really comes to mind when I think about how do you be successful with this, the saying actually from my dad, who's a pretty old school electrician. I'm sure if somebody told him it. It's make the plan, work the plan. And I just want to talk a little bit about what goes into that. And by the way, for slides, I printed them out. I can't even see that, but so you could just kind of, whoever's running the slides, you can just try to keep up. And if I move on, nothing's profound in the slides. So I think I'm 2 slides ahead right now. All right, make the plan and work the plan. Okay, so what is making the plan? The number one thing is make the plan ahead of time. I see a lot of okay, they installed a bunch of stuff and now they're going to make the NLC plan, and it's a little bit late and it's not going to go great. So make the plan ahead of time. All right, and if we could do one more slide. I don't know if I should just wave or anyways. Okay, so make the plan ahead of time. Include all of the decision makers when you're making the plan, because NLCs are not exceptionally challenging, but you got to keep all the perspectives in place so everybody knows that it'll work for them. Keep the plan functional and avoid fancy. There's lots of really good systems out there, and they have tons of crazy features. I recommend not using them unless there's a specific purpose towards using them. Generally speaking, the simpler projects seem to go smoother, and they seem to have happier end customers. I would say consider real world limitations, and that's a very broad topic. You've got to be familiar with whatever system you're trying to put in, or you have to have somebody involved in the planning process who is familiar with the system. But basically, just try to make sure the system can do what you're asking it to do. I'll get more into that later. But yeah, if you spec something and install something that can't do what you're trying to do, you're just not going to have a good time. And then lastly, communicate the plan to all the relevant parties, end customers, the person commissioning, installers, the IT department. And I say that because oftentimes, 2 out of 3 people involved will know what's going on, and then the third person struggles to execute the plan. So those are the takeaways for making the plan. For working the plan, it's pretty straightforward. Right equipment in the right spot. The person commissioning commissions as planned, and then actually communicate with the end users. I'll talk more about that later, but really it's just working the plan that was made. All right, this is my favorite slide coming up. I can't believe they let me put this in here. But my favorite Dwight Schrute quote: before I do anything, I ask myself, would an idiot do that? And if the answer is yes, I do not do that thing. And I like this because, well, one, it's a little bit funny, but two, I think most people out there are actually pretty smart, and the mistakes don't actually happen through lack of intelligence. They just happen through either lack of planning or communication or coordination. And I just wanted to put that out there because, really those are the pitfalls that make something not successful. Okay. So, and lastly, before I get into some stories, whenever you're done working the plan, so you've made the plan, you worked the plan, now you're done, there's a little bit of change management and just double checking that it has to happen. Make sure the space is functional before you leave. And, that's different for every space, but just make sure it works. I would strongly recommend resist changing the plan before customers have had some time to get comfortable with the changes. Tell them, hey, this will work for you. It'll work great. It's going to be different because you're used to switches and now you've got sensors. Give us 2 weeks and then let's see. Then let's tweak it from there. The majority of the time, if the place is functional and the plan was decent, in 2 weeks, they're going to like it. They just have to get used to it. And different people, if you're in a building with 20 people in there, you'll have 20 different opinions. All 20 need some time to get used to it. And then lastly, kind of to that first point, if there are functional issues, adjust them by remaking the plan. Don't do any impulsive fixes that don't have, everybody involved in the conversation. And you could do a quick change, just get everybody involved. What you want to try to avoid is one person has a problem with the way the space is working, so they say, hey, let's do it this way. And you make that one change real fast, and then 2 days later, you get a phone call from 3 other people saying, hey, that one change was good for them, but it jammed us up over here. So if you have to make a change, slow it down just a little bit and make sure it works for everybody. Cool. All right. And then now we get to the fun part, the what not to do. These are lessons we've done a lot of projects on several different systems, and I've supported people installing them on them, and it's lots of lessons. So what not to do. Don't put the sensors on one side of the building and all the wireless control modules on the other. Without diving too deep, some systems have sensors and then followers. And you basically zone them up so they operate all together. I've seen more projects than I care to admit where the installers just started slapping lights up. And the way the lights shipped, they've got a skid of lights with sensors and a skid of lights with the follower WCM units. And the left half of the building is all sensors. The right half of the building is all followers. There's no way to commission the building. There's no way to set the zones in a functional way. And it's a lot of rework that could have just been avoided by making sure that the installers knew the plan as well. All right. For the next one, don't try to install an internet gateway in a building that has no internet, because it doesn't work. Not every system needs a gateway, and some people want it for different functions. Some people don't want it for security reasons. That's a whole nother webinar. But I see a lot where they put a gateway in a building and there's no internet. So the gateway just is this device that can't do anything. I see it a lot at park districts, shipping yards, bigger production facilities that have like a big giant yard with different, I'm gonna call them outbuildings. That had they planned it, they would have realized it's not gonna work. All right, this is a fun one. I've actually only ran into this once. Don't try to run the wireless network through a mountain. It was a ski resort that somebody was doing. They had kind of like a remote parking lot, and it was literally on the other side of the mountain. And they just couldn't understand how the Bluetooth mesh has some range limitations, and you couldn't have the two parking lots act as one. There were some workarounds. So, in the end, it was successful, but yeah, the original plan just wasn't going to work. On a smaller scale, whenever you're doing the plan, you should have somebody who's familiar with the site and somebody who's familiar with the NLC system. I see a lot of just not understanding range and how that impacts it. A lot of subtleties like that, where many systems have their standard device with the standard range, and they'll have a device that has a longer range. And if somebody had said, hey, let's just pop a couple of these long range devices into the system, they would have had beautiful connectivity and a smooth, easy commissioning, and everything would have worked out of the box. But because either the person planning wasn't familiar with the site or wasn't familiar with the system, then they have some connectivity issues, and it's just not smooth. All right. People management. The next thing not to do, don't let your customers follow you room to room negotiating the settings for each of the room. I've seen this happen a lot when the plan isn't made ahead of time. You show up on site, your customer's there, you're talking, and you're like, yeah, we can set the system up, everything's going to be great. And then they start wanting different profiles for each room. I was supporting an ESCO that was commissioning a library, and there were 5 very nice librarians that were a little bit nervous and pretty opinionated, and every single room in the library was kind of like this 10-minute negotiation of what setting should we do. And I mean, we spent, I think I did the average, it was 150 lights in the library, and we spent 3 hours negotiating the zones. So it only took us 1 minute per light to negotiate the settings for that room. I mean, it was just, it was painful. And it all happened from not planning ahead of time, and then people feeling like they needed to make decisions and have an opinion on site, but they didn't have time to think about it. So it just slowed it all down. And then This last one, super simple. Don't forget to tell the building staff that the lights are now on sensors. Um, I don't think there's a week that goes by where we don't get a phone call from somebody really flustered first thing in the morning, being like, somebody installed lights in my building yesterday and they're all broken today. And it's like, kind of gotta, ask all the information, and it's like, your lights aren't all broken. They didn't all break overnight. What usually happens is there's a maintenance person or somebody else in the building that's unaware that there's now a lighting system with network lighting controls in place. They're unaware that all they have to do is leave and the lights will turn off automatically. But they have good intentions. They don't want to leave without the lights going off. So then they go over to the panel, flip the breakers. They don't tell anybody. Next person comes in. They're trying to open up, get their day going. There's no lights. They get flustered. It's just a communication thing. Not a big deal, but we get a lot of phone calls about that. And it's always just, hey, make sure everybody knows about the system. I would say there's a million stories out there, but these are the big ones. When you're doing an NLC system, any system, make the plan, work the plan, and thank you for your time. I think we've got Jason. Do we have Q&A now?
Yep. Thanks, Kirby and Frank. Let's see if we have any questions. Please put your questions in the question pane. And just to start us off, Kirby, I'm going to say, what do you think is the best first step for a contractor that came to this session and said, oh, okay, now I can do this? Like, what's the best first step for a contractor to get into network lighting controls? Say they've been doing standalone controls for X number of years, and they're willing to make the leap to networked.
We didn't prep these questions.
I didn't prep.
I love it. I'll say that the contractors who are successful on the install, they usually go slow before they go fast. And I remember I got a call from an installer, and it was Sunday morning. This installer did a lot of schools, and it was fixtures with NLC, but it wasn't the system that they normally used. And I assumed that they were on site with a bunch of problems, and that's why they're calling me, like doing a weekend school install. And then he was like, oh, no, I got the lights set up in my kitchen. I want to be comfortable with the system before I get in front of my customer. And I was really impressed with that. Set up 2 lights, set up a mini zone, extension cords, on a bench. Do that before you dive in, selling projects and getting in front of customers.
Great. Let's see. We had one question I'm going to take. How have you calculated your lighting control savings after installation? If you used meters or loggers, what was the sample size for the 49% number? So I'll tell you that came from one of our published reports entitled Energy Savings from Network Lighting Control Systems with and Without LLC. That was first published in September of 2020, and then it was updated just a few months ago with some clarifications. That report is available on our website, and it's one of the links that I showed earlier in the slides. So I'm going to point you to that because that has all the details on where that number came from. Also, that number is an average for the NLCs and does not include the LLCs number, which is in the 70s%. So there's, I'm being very conservative with my claims here. Let's see, Frank, here's one for you. Frank mentioned open systems. Are there open systems available in the marketplace?
The answer is absolutely. So yes, we're all familiar with some of the tier 1 companies who have proprietary systems. There are quite a few companies, without naming names, they will have their own sensor built into, let's say, a trough or door kit as an example, or a vapor tight. Now, they will also produce what I referred to as the dongle, right? Really, it's a wireless node that gets wired into someone else's fixture, and as long as you've got a 0 to 10 volt driver, that dongle handles the driver and the load. So it doesn't really know that it's not manufacturer number one. So as an example, you're doing a retrofit project and maybe there's a wing of a hospital or some other building that was retrofitted a few years ago with another manufacturer number two. You could come in with an open system and kind of, I don't want to say hijack, but you could, control the entire system regardless of which manufacturer. So there are some benefits to that type of system.
Great. I'm going to add to that also. Names we can mention are Dolly, was an open standard, and then the Bluetooth SIG has just published Bluetooth NLC, which is an open standard as well. There are systems using those two things available on the market as well. Another question: how long is the simple payback for a typical project that adds NLC? Like any sense of how long is adding network controls increase the simple payback?
I'm sure we all have an answer to that. I love how the word typical was in all caps.
Mm-hmm.
I would love to know what typical means in your eyes. I will say that in the older days, adding a control system would many times improve the payback and make it shorter. With today's first gen LEDs in other systems, it's becoming more and more rare for an NLC system to reduce the payback. Many times it's kind of payback neutral. To answer your question, it could be 3 or 4 years. It could be 10 or 15 years. It really is a function of how many watts are being saved, what is the cost of electricity, and what's the percentage of time that's being reduced. So each one of those will drastically affect what that project will be.
And I want to add, it depends on the customer, how they were using their old lights. If they left the lights running all the time, those sensors are going to pay for themselves really quickly. It also depends on, is there a utility rebate? Because it's certainly not this way across the entire country, but there's pockets of the country where that rebate pays for the sensor. So the payback is instant. That sensor is pretty much free. They're paying for other parts of the job. So it's a really tricky thing to answer. Yeah, I think most of the time it pays for itself pretty quickly.
Great. Another good question that came in, and this is related to a third question. So what is the best way to transfer controls to the facility manager after commissioning? Remote control or cloud app account set up with privileges? Do you sometimes leave a tablet device with the app installed? Like, how have you guys managed that? I'm gonna go Kirby.
Okay, I'll dive in. Okay, so in Jarvis Lighting, we're a lighting company. We supply material and then we support companies doing these projects. So I'm saying that because ultimately this is usually not our decision. So I've seen it done a lot of ways. Recently, I don't see a lot of like leaving a tablet on site. I see some companies that don't really do a handover. I don't think that's very successful. I understand they're trying to avoid customers making a lot of changes and then calling because their lights don't work. I see this all the time where it's like, oh, there's a site that's not working with whatever control system, and you look at the profile adjustments and you're like, there's no way any lighting professional did this. It was somebody on site making changes, hit the wrong button, nothing works. Most of the systems out there, you can give limited access to the end customers. If everybody has time and the appetite for it, because some end customers don't want to learn anything about the system. I think the best way to do it is you give the admin account to whoever is the admin on the company. It's their lighting system. They should have control over it, but you give the caveat like, hey, don't mess it up because you can make some mistakes. It's, don't change it too much. And then they can dole out, if they've got a trusted facilities person that can also be an admin, if they've got other users who they want, very limited access, they can give that out. But I recommend don't give the admin stuff out to everybody because it's just a recipe for a disaster. It's like Play-Doh, they start mixing the colors and then suddenly like they're mashing everything and then it's just all brown. So.
I have a niece who can't stand that. If you mix Play-Doh colors, she goes crazy. So kind of a related question, for a space where the existing occupants may not be there permanently, say it's a rented space and the tenant that installed the system moves out, any tips for recommending or for ensuring that access to the controls gets transferred to the next person responsible for that space? If there's anything that we can do from this end for that. Maybe a paperwork packet emailed to everyone and their daughter.
Okay, so, and Frank might have a different experience than I do. I see this a lot, and it's a real problem because you can't give everybody an access to a system. The best way to do it is if somebody from the landlord and somebody from the tenant has access to it. Then the person who the entity that sold the job, they're kind of hands off because they're like, hey, the landlord had it, the tenant had it. If it's a different tenant, at least the landlord's got it. If they're comfortable, keep somebody from the ESCO or the turnkey lighting company, keep somebody on there so that at least they can get back in after the fact. But some end users don't want that. They want total control over their system after it's installed. It's tricky as far as knowing what the system's doing. The leave behind packet, that's really good. I've seen it also get lost before. It's a tricky challenge. Communication on that and being organized is really a challenge. You just have to make a decision and make sure you follow through with it.
Yeah, that makes a lot of sense, Kirby. I agree, having the building owner, whether the landlord, whoever it is, who's going to be there regardless of tenants coming in and out. That does seem to be a recommended practice, to have that person with an admin, username and password, and then as the tenants come and go, you can kind of have the place of control there. And then part two is to having that communication between the tenant and the ESCO, depending on that relationship. So I don't think there's one right answer, but it just really is a function of the sales team staying in communication with the end user.
Great. Different subject. Any tips on how to measure natural light coming in through windows and skylights for daylight harvesting? I think this has to do with probably two things: context of whether or not to choose daylight harvesting as a strategy, and then once you've done that, how do you make sure that the system is calibrated correctly? I'm going to tackle the first one. My personal opinion, in a small building, particularly with an NLC system, just turn on daylight harvesting. It's not going to cost you anything more for the hardware. It's a software setting. And then turn it on for everything that has a sensor. So then you don't have to worry about primary daylight zones and secondary daylight zones and top lighting zones and side lighting zones and 1.5 times the window height and like all of that business. Just turn it on. And then you'll get the savings you'll get, and you might even get more savings because you might have a luminaire that is just outside of a code daylight zone that can still dim some and save some energy. And I'm going to throw the next part of that question back to you guys as far as like tips on measuring things to make sure that stuff is calibrated correctly. I know it's different for each system, but any ideas?
Okay, I don't know if I'm supposed to say this. Here's my very candid opinion on daylight harvesting. Um, I think it is a really good thing, and I think if you try to like 100% maximize it in a building that's a retrofit application that wasn't meant for daylight harvesting to begin with, it kind of sours people's opinion on daylight harvesting. Because you can have, a desk that's got really good light, but it's all horizontal. So the sensor's picking up really good light on the desk, but it's not really usable light for the end customer. And you see that a lot in office buildings that just were never designed for daylight harvesting. So the way that I see it being addressed is daylight harvesting is used a lot, but they trim it so that light that zone that's utilizing daylight harvesting, maybe it could dim down to 20%, but they trim it so it only dims down to 50%. And you give up a little bit of energy savings, but it kind of covers up some of the, I'm going to say, architectural challenges for a building that wasn't designed for daylight harvesting. Again, like the horizontal window, because the windows are, pretty low or something like that. Because what I found is a lot of end users, if the daylight harvesting isn't working correctly and the space is not usable, they get really frustrated. They don't want to take the time to calibrate it. They don't want to do any of that. And then they're just like, okay, turn it off completely. And then you lose all of it. So I don't know if this aligns with DLC's opinion on it, but my personal opinion, do it in moderation so that you know it's going to be successful. Frank, do you have any? Well,
Yeah,
yeah.
yeah, no, those are very wise words. I think just generally speaking, some of the best daylight systems are the ones where you don't even realize they're there, right? You just want it to act invisibly when you do have that beautiful daylight coming in. Let's turn off the electric. It should be imperceivable, to the users. It's when it becomes noticeable, or there's an abrupt click off, or you're not getting the proper, setbacks. That's where you can get into issues. So I guess just do your homework up front, and specify a system that allows for that automatic setting and for that commissioning process. So hopefully all the work's being done in the sensor, and as long as you adjust your top and bottom ends, you hopefully will have something that works well.
All right. Um, Another question, and I'm going to take this. So how do you communicate that the design and NLC settings are code compliant to the plans inspector and the building field inspector, both the safety and energy codes? Uh, well, there's a new standard to do that that was just published this spring called C137.9. It's an ANSI NEMA standard. I was on the committee that wrote it, so I'm very excited about it. It is a standard for NLC configuration reports. When the standard is adopted by manufacturers, hint, hint, Kirby, the programming device for a system, so in many cases like a mobile, an app on a mobile phone, will be able to generate a report organized by space type of what are the settings for all the devices in each space type in that system. It's generated from the network itself after programming, and then creates a PDF, and then you can send that into your efficiency program if you're getting incentive out of it, or you can send that to your building inspector to show that these spaces have these settings, this timeout, and this high-end trim setting, and daylight harvesting is enabled here to prove those settings are in place. At the DLC, we will have a webinar dedicated to this report standard coming up in October. So please start asking manufacturers for that and sign up for that webinar when it comes out.
And I'm going to add, so there's two parts of this. So everything Jason's talking about is perfect, and it's so much easier after it's already been commissioned. On the front side, before the project's been done, let's say you're in permitting and you're in a place that's very strict and wants to see all of this. Generally speaking, they're going to kind of put this in the same bucket as either photometrics or other lighting type stuff in the permitting application. I don't know of any control system that will let you do this ahead of time. So then I would recommend just do a traditional, like you're basically going to type up, hey, here's our lighting plan, here's our controls plan for each zone. And it's a little bit extra redundant typing, but that's actually awesome because when they're commissioning it, you can hand that sheet to the person commissioning it and they've got a written plan. So on the back end, everything Jason's talking about is so much better than it used to be. On the front end, it's still manual.
We had a couple of follow-ups on that. The C137.9 is the number of the standard. Currently, it does not cover emergency lighting for testing for those. That's a different world. Perhaps we can add that capability to the standard later on. But right now, it doesn't do emergency testing or proving that you've got 1 foot candle in your exit path and all of that. That's a different thing. We got a couple more questions. So in the shipping yard example, is Starlink the only answer? Related to this question, is there a value in having an in-house networking expert for gateway and network communications setup? I think this would be for like a installing contractor or ESCO.
Yeah. So the short answer is no. The longer answer is system choice and component choice will give you a firm yes or no whether or not it's going to work. So, and there's lots of Bluetooth systems out there. There's also some systems that are not Bluetooth. And generally speaking, most standard Bluetooth nodes are a range of 50 to 200 feet, depending on the component and the system and all that. Most Bluetooth systems have something with an extended antenna on it that can extend that out to say 500 or 600 feet. So depending on the size of the yard, you could develop a plan that runs on Bluetooth where it's got enough of those, we call them long range WCMs, but everybody's got a different name for it. And if the person commissioning it knows, hey, I need to set that one to a relay so that it's basically repeating everything that it hears in the Bluetooth network, that can be a solution where you get reliable signal all the way back to wherever internet is. If that's not an option, there are systems that have long range devices that might have like a half mile or a 1,500 foot range. And then there's at least one system comes to mind that has a gateway that has a cell chip in the gateway. So it just uses, I'm going to guess 4G internet. So it's not Starlink, it's just built into the gateway and it just runs. You plug it in and it goes. So the short answer is no. There are more options than Starlink. You just have to dig deeper into the NLC system design to make sure it's good.
Great. I'm going to say one. So a question of what are some different ways to estimate motion savings? I'm going to say typically I would suggest going to one of those technical reference manuals that we spoke about briefly earlier. So TRMs are usually state or region level public documents that describe energy efficiency measures across all sorts of areas, from lighting to refrigeration to all sorts of things. And many of them include, or based on research that include savings claims for specific measures. So Illinois is really good at theirs. The Illinois ilsag.org, I think, is the URL for that. But they've collected a bunch of research and they've put together a range of savings by building type or space type that utilities can then claim for specific technologies. So if you put on occupant sensing in a warehouse, you can save X percentage, whereas occupant sensing in a open office area will save Y percentage. So those are the best ways I've found to do that, is kind of lean on the research that's already been done and instead of trying to name it up yourself.
Yeah, there's
Um,
something to add to that in a more of a generic sense, right? We're either going to stipulate what the energy savings percentages are, or we're going to measure using data loggers. And so you can measure, the before and after hours of operation. There are some loggers that will measure both the time that the electric lights are on and is there occupancy during that same time period. And so if the lights are on 16 hours a day and there's only people in the space 8 hours a day, as you know, there's your 50% that you've documented, because it's pinging. I think it's every, what is it, 6 seconds or whatever that time period is. It gives a very robust look. So if you're not going to, make the effort, then really it's a bunch of stipulations as related to those documents that you're talking about. So it's as long as the customer and the developer have an understanding, there's, it's how right do you want the answer to be? Because it's always going to be somewhat of a swag, no matter how far you dive into it.
right. All right, I'm going to go with one more question, which we might not get to because it's a big one, but we'll start it and I can follow up afterwards. How do you convince the specifiers, lighting designers and engineers, to ensure that their specified light fixtures can take LLC or NLC components that match those on the specified lighting control systems? It seems the LDs and engineers continue to specify without talking to each other, and it's almost impossible to bid a complete project. I'm going to say I don't have a straight answer for that. And if you do, let me know so we can make a lot of money together. Unfortunately, getting lighting designers and engineers to talk to each other is always a challenge for everyone, including them. And for that question, I'll follow up with you for some more details, because it sounds like there are some details there I'd like to get to. All right, so that's what we've got. Thank you everyone for joining us. Thank you, Frank and Kirby, for presenting. And I hope everyone has a great day. And let's go specify some NLCs and LLCs. Oh, next screen, please. Here are our names and emails. So please feel free to reach out to any of us if you have any questions or would like to discuss further. Thank you.
Thank you.
Thanks, everyone.